Hey guys, today I want to teach you decimals, expansions, and binary expansions. Okay, so decimals, um, hope, hope it is clear to you guys. Decimals and binary expansion. Okay, we know decimal is always based upon what? Decimal is based upon 10. Dec means decimal is always based upon 10, and just remember this. By this time you already would have known this. Binary is based upon 2. Okay, remember these two things, it's very easy. So decimal, hope my camera is clear. Decimal is based upon 2 and binary is based upon decimal is based upon 10, binary is based upon 2. Okay, so let us solve one decimal problem and then expand them. Let us do 12, number 12. Okay, expand, this is a decimal number, expand, do expansion, or in another way, write the decimal expansion of the given number. If the question is asked, write the decimal expansion of the given number. So we need to expand them. This is based upon 10th, right? Unit tenths or ones tenths. So this is based upon 10, so we can write 1, right? 1 times 10 to the power 1, right? Plus 2 times 10 to the power 0. This is done. This is how you expand the number. Okay? And this is how you expand the number. Let me do another way. This is how we expand the number. Okay, let me do this way so you guys can make it clear and understand. This is how you expand the number. Now let us prove by solving this so that we should get number 12. Okay, let us prove this. If there is another number, example 2, we multiply 2 times 10 is 20, but here is 1, so that doesn't make changes because we have only power 1. If there is a power 2, we should have 10 times 10 is 100, but here is 1, so it doesn't make changes. So that is 10, we know, plus here we have 2, and then times 10 to the power 0 is 1. Any number power 0 is always 1. Remember that. Any number power 0 is always 1. Do not forget that. Remember that. So we have 10 here plus 2. 2 times 1 is 2, equal to 12. Boom. Proved. This is proved. This is equal that. That is proved. So this answer is correct. Okay. Another. Let us do a little bigger number. Okay. Let us do 205. Okay. Let us expand this decimal to this expansion way. What is this? Unit 10, 100. So this is 100. So we know 100 has two zeros, right? 10 has, this is 10 has one zero. This number is based upon 100. 100 has two zeros. So always write 2, 1. Here's 1, here's 0, like that. So we have 2 times, since this is decimal, so based upon 10, 2, because 1, 2. Always you can 1, 2. How many numbers? Plus 0 times 10 to the power 1, right? That is 1, plus 5 times 10 to the power 0, guys. 5 times 10 to the power 0, right? Now, this is how you do the expansion with this decimal number. This is boom. But let us prove it. Let us prove so that we should have getting this number, solving this number. Let us prove it. Yes, now we have another bigger number here, not 1 like this. We have 2 here, so 2 times 10 is how much? Just write 2 times, this is 100, right? 10 times 10 is 100, plus any number. 0 is 0. We don't get anything from here. Here, what do we have? What we have is plus, we have 5 times any number power 0 is, guys, 1. Remember that. Don't forget that. Any number power 0 is 1. Let's solve it. 2 times 100 is 200, plus, we don't have value this. We do not have to worry about this. 5 times 1 is 5. Add this. How much do you get? 205. Proved. Our answer is proved. Boom. This matches this. So that means this is correct. This is correct. Got it? You got it? Okay. Now, let us do the binary. Okay? Binary is based upon 2. Don't forget that. Binary is based upon 2. Let us do an example here. If you are given 1, 0, 1, 1, 2. This is binary. Let us convert this to expansion and convert to decimals again. Okay, this is quite longer, but it is so easy. So how many numbers we have? 1, 2, you need 10, 100, 1000. This is based upon 1000. Thousands have 3 zeros, guys. So 1, 2, 3. 1 times 2, because this is based upon 2, we cannot write 10 here. Binary is always 2. 1 times 3, because we have 1, 2, 3. Just count, except this first number. 1, 2, 3. And what is the number that I write here on the power of this 2 based upon 2? Count this number, except this first. 1, 2, 3, 3. Plus, what is the second number? 0 times, we don't have to forget, we have to remind that number 2 is the best number based upon 2, so 2 to the power 2, plus, we have this one again, right, times base 2, 1, plus, this is last one, times 2, 0. Boom. This is how you write for this binary. This is an expansion way of expanding numbers. Okay, now for the given number. For the given binary, we're expanding this way. So now let us solve this, how much we will get to prove that our answer is correct. 2 times 2 is how much? 2. But we have 2 to the power third plus any number power 0 is 0. Don't have to worry about that. 2 to the 2 times 1 is 2. Power 1. We do not have to worry about that. Plus any number power 0 is 1. Any number power 0 is 1. Forget about if there is a 0 or 2 or something, then you need to worry about it. If there is a 0, you always write 1. Don't forget that. Even here is a 0, like here, don't neglect with 0 here, because this is any number power 0 is always 1. So even here is a 0, you need to bring that 1 here. Okay, so let us add it. 2 to the power third is 8, right? You know that this is 8. How? Because 2 times 2 times 2 is 8 plus, don't add this, 2 times 1 is 3. Okay, so we have how much? 11, guys. 11. This is a decimal number. We got 11 here. This is a little longer, but bear with me. Let us solve this. We know we have our formula that 228 64 32, right? 16 8 4 2 1. So this is 11. 16 is bigger, way bigger than 11. We can do 8. 8 minus 11. Okay, let me calculate it so that so 3. This is bigger. We cannot do this. 1. We can do this. Minus 2. Then 1. Boom. So number 11 is our decimal number, and when you convert this decimal, we should get 1011. Do you believe me now? This answer is proved with this, right? 1011. Our answer is proved, and we just have to do 2 here because that is based upon 2. Got it? Let us do one last example for binary. Let us do one last example. So let us do a little bigger number, okay? 1. Let's do a little bigger number. 1 0 0 1 1 0 1 1. Okay, my handwriting is not good, but bear with me here. Okay, now this is best of 2. This is the questions, and it is asked for the problem, write the binary expansions of the given number. So this is how it will ask. Write the binary expansion of the given number. Given numbers. Okay. Write the binaries of the given numbers. This is the questions. This is how it has been asked for you in the exam. Okay, now let's solve it. How many numbers we have? 1, 2, 3, 4, 5, 6, 7. Just count that number. 2 to the power is 7. The first number is starting with 2 to the power 7. We know that. 1, 2, 3, 4, 5, 6, 7. Because this is based upon 7 numbers. So we know now. Now let's do it. 1 times 2. Since this is based upon 2, this is binary. 2 to the power 7 plus 0 times 2 to the power 6. Let me write this to not make you confused. Okay, and 2 to the power 6 plus another 0 times 2 to the power 5 plus 1 times 2 to the power 4 plus 1 times 2 to the power third plus 0 times 2 to the power 2 plus 1 times 2 to the power 1 plus 1 times 2 to the power 0. Done. 1, 2, 3, 4, 5, 6, 7, 8. All numbers 1, 2, 3, 4, 5, 6, 7, 8. Boom. This is how you expand the number, the binary number, to the expansions to the given number. This is how you do it. But let us prove it if our answer is correct or not. Okay, you can write only this much, but some teachers ask you to prove it. So let us solve it. 2 times, we have 2 to the power 7, right? 2 to the power 7 plus, this is 0, you do not have to do it, this is 0, this is 2, 0, this is plus 2 to the power 4 plus 2 to the power third plus, this is 0, and this is 2 to the power 1, which is 2 only, and plus 2 to the power 0 is 1. So let's do it. We know this is 2 to the power. This is how you guys have to remember. This is how 1 uh, this is how you guys have to remember this. Always 128, 128, 64, 32, 16, 8, 4, 2, 1, right? So this is like 2 to the power 0, 2 to the power 2, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. This is how it is proved. So we know 2 to the power 7 is 28, 2 to the power 6 is 64, 2 to the power 5 is 32, 2 to the power 4 is 6, 2 to the power third is 8, 2 to the power 2 is 4, 2 to the power 1 is 2, 2 to the power 0 is 1, right? That is how to any number power 0 is 1. So we know, don't be confused here, we know we have this here, okay? Just this. After we calculate this, we got this. So we know 2 to the power 7 is how much? 28 plus this 0, 0 don't have value. 2 to the power 4 is how much? We know 2 to the power 4 is 16 plus we have 2 to the power 8 is 2 to the power third is 8 plus 2 to the power 1 is 2, right? And 2 to the power 0 is 1. We have 1 here. So we did this. Now let us add this. Let us add it, and then there. Let us add it. Okay. Let me add in my iPhone. Okay, to make sure 128 plus, we have 16 plus 16 plus 8. 128 plus 16 plus 8 plus 3. So this equal to how much we get? 155. Okay, so this is our decimal number. You remember, this is our decimal number. Let us convert this decimal to binary, then we will get this number to prove our answer. So we have 155, our decimal number. Let us prove this. 128, just formula. Remember, 32, 16, 8, 4, 2, 1. So we have 155. We can subtract 155 from 128 minus 128 equal 27. We cannot do this here. We cannot do here. We can subtract 16 from 27. 16, which will give 11. We cannot go, yeah. Yes, we can go 11 minus 8, which gives 3. 4 is bigger. 0, we can do here. We can do here. So our 55 decimal is 1 0 0 1 1 0 1 1. Let us match this number with this number. Do we get the same number? 1 1 0 0 1 1 0 1 1. Boom, proved. Little messy, but it is proved, guys. Let us do another one. Very simple one. Okay, let us do this. Did you do that one? Okay, let us do this. Simple one. 1 1 0 1 2. We have given this binary to, and we do the expansion. 1 2 3. Let us do 1 times 2. This is 3, plus 1 times 2, 2, plus 0 times 2, 1, plus 1 times 2, 0. Let us solve this. 2 times 3 is 8, right? This is the answer. This is how you write for this, but let us prove it. This is 8 plus 4. This is 0 plus 1. Here we have to 1, right? Let us add it. 8 plus 4 plus 1 equal to 13. We just give 13. Right? This is our decimal number. Okay, 8, 9, 10, 11, 12, 13. So let us do 13. So we have our number. Let us do 16, 8, 4, 2, 1. Okay, 13. 16 is bigger. We can do 8. We can, okay, minus 8. We have 5. 4. We can do 4. Minus 4. We can do 0, 1. So for this is, I didn't write 32, 64, 128. You need to, I just wrote because this 13 just goes after 16. I knew that, so I didn't write that unnecessarily. You need, I think by this time you already know these things. So we have, for 13 decimal, we have 1101. So this is based upon this 1101. Proved. This is proved. Hope guys you will, if you like my videos, if you like my math, I will be helping you guys in a lot of these binaries and decimals and hexadecimals. Please subscribe my channel, okay? That will help me. Please subscribe my channels. That will help me. Thank you guys.